Okay, welcome everyone to the second experiment. Okay, this is about three-phase power measurement. So from the name itself, you can understand that we will deal with three-phase circuit, right? Yeah. So in the first lab which we had last week, we didn't deal with any three-phase circuit. Remember? Yes. We deal with single-phase AC and the DC circuit. Yes. But our first target or first focus was to get introduced with the KCLab software mostly. So that's why we just picked some very easy circuits and we just show how to measure the voltage and current. Now today we're going to deal with a three-phase power measurement circuit, and this part was completely covered in our lecture. Can you remember 2 wattmeter method? I think like the second half of the lecture was regarding the power measurement in three-phase circuit, right? Yes. And we measured the power using the 2 wattmeter method. So remember the method, it was known as 2 watt meter method. Okay, and from this method we can get the total power PT and QT and the angle theta. Yes. Remember? And can you remember the equations? Yes. PT was P1 plus P2. Yeah. Okay, QT was root over 3 P2 minus P1, and theta was tan inverse QT divided by PT. Okay, I will very quickly show you the circuit once again, how we will take this data and so on. So actually we'll make a three-phase circuit and we'll measure the power from there. So now, as you all know that how the circuit looks like, okay, the circuit, whenever we make any circuit, of course it will go with a three-phase source, right? So it will go with a three-phase source. So that means we have L1, L2, L3 and neutral, right? So three-phase circuit source means L1, L2, L3 and neutral. So from there, second step is just the fuse. Sorry, I think I should. The fuse, okay? From the fuse, it will directly go to the load, right? Now tell me what type of loads we have if you want to make the three-phase network. It can be of 2 types, right? Yeah. Either Y or delta. Okay? Now inside the Y, actually we have 2 options. One option is inductive, that means that will be RL, okay? And that another will be capacitive, which is RC. Yes. Similarly, from delta, either we can have RL or RC, okay? Yeah. So actually in the lab manual, it is asked to do all the 4 different types, okay? So like once you do the first one, the second one is just changing the arrangement from inductor to capacitor, from Y to delta and so on, okay? But actually if we want to do all the 4, it will be very time taking because repeating the same thing again and again. Yeah. So mainly we will focus on Y type of connection. So we'll make the connection and we'll just replace the L by C. So this will be our load, right? So just remember like how the circuit will look like. Okay, if it is a 3-phase source, so we will have a 3-phase load, right? If you want to make it RL, so of course RL, RL and RL. The load will look like this, isn't it? Yes. Yeah. So L1 will be connected with here, L2 maybe with here, L3 will come here, and the neutral will go to the neutral, isn't it? Yes. Are you with me? Yeah. Yes. This is actually the connection. This is actually the connection we will make in the table, okay? Now, if we want to make it RC, what we will do? We will just replace the inductors with capacitors, simple. So just make it a capacitor. This is what we will do. So the connection is clear? Yes. Yeah. Now, where the KCLab will come into act here? This is the main question. The KCLab, can you remember how we do the 2 wattmeter method? In order to do the 2 wattmeter method, remember, we need to measure current here by putting ammeter, yeah, yes, and voltage here between these 2. Yes. Remember? So for example, this is 1, so we will get from here I1, and the voltage from here we will get V1. Are you with me? Yes. And now if we select RMS quantity in the KCLab, it will give us cos theta 1 also, right? Yeah. So we will get V1, I1 and cos theta 1. Is it clear? Yes. Yeah. In the same way, what we can do, we can just put another ammeter here and a voltmeter between this and this. Okay? So from this ammeter, we will get another current which is I2
and V2.
And from here V2. And of course, we will get the power factor between them as well, right? Which is cos theta 2. So cos theta 2. So now how do we use the equations? So it's very clear that from these three, actually we can measure the power. P1 equals to V1 I1 cos theta 1.
Yes.
And from here we can measure P2, which is V2 I2 cos theta 2. So this P1 is this P1. Are you with me, guys? So this P1 is this P1. And this P2 is this P2. Is it clear?
Yes.
So whenever
we can measure the reactive power from changing the cosine to sine.
Actually Casilab cannot give you sine.
Oh, yeah.
The Casilab gives you only the cosine angle. Okay, so it cannot give you sine. So here we will measure actually the power factor and then from P1 and P2. Okay, so once we have P1 and P2,
but if we have the
formula.
angle,
Yes.
we can find.
Yes, you can find, of course. So you see, like if you have P1 and P2, so you just add them, P1 and P2, you will get the total P, which is PT. And using this formula, you can get P2 minus P1, right?
Yes.
Are you with me?
Yes, sir.
So these formulas, how they are coming, we explained in detail in the lecture class. Remember?
Yeah.
Remember in the lecture class, we showed you the proof that how these P1 and P2 and PT, these formulas are coming. And also one more thing I showed you, remember the phasor diagram?
Yeah.
I showed you that this angle is actually 30 plus theta.
Yes.
Remember I explained almost, it took almost 20-30 minutes. And here this is actually 30 minus theta.
Yes.
Can you remember from the phasor angle? So actually what Casilab does, he calculates the total angle as a cos theta. He gives you the total value together. So you don't have to plus 30 or minus 30 by yourself. Okay. So this is how we will do today's experiment. Okay. Now you can understand that this V1, V2, this V1 I1 cos theta 1 and this V2 I2 cos theta 2, all of them we will get from Casilab. You understand? We'll not measure the voltage and current by our hand. Rather, we'll just connect with the Casilab and we'll get it directly. Okay? And also, what we'll do, we will plot the curve of voltage and current versus time, and we will see some curves, how it looks like, and so on. Okay? So because you know that in the Casilab we can plot different type of curves. Okay, if you just select the time scale, it will give you the curves automatically. So that's why if you say what are the objectives of our today's experiment, I'm just making it short now. First objective is to find out the three-phase power from a three-phase network. It will be an RL network and also an RC network. And to measure the three-phase power, we'll follow the 2 wattmeter method. We'll take the help from Casilab software. And the second objective is to see the behavior of the voltage and current with respect to time. So that means we'll plot some transient responses where our x-axis will be time and it will vary the voltage and current with respect to time. Any question from your side? Okay, thank you. So what we have done, we have connected the circuit for RL load, right? So you can see like this is the circuit we have drawn. So as I have shown in the board, so it has a source and it has a load R and L. They are connected in series, RL and RL, and because they have a star connection, so you can say like all of them are joined together. So these are the 3 R's we have, R1, R2, R3, and this is L1, L2, L3. And this point is the point in the center to make it Y. Remember, to make it Y, all 3 branches needs to come in a common point, right? This is the common point where we have just connected the 3 branches of a Y connection, okay? And here we are taking the source from three-phase source, L1, L2, L3 and neutral. But have I connected the neutral? No. No. Because neutral connection is not mandatory if the load is 3-phase. You understand? Because if you connect the neutral, it will be a 3-phase 4-wire system. Remember in the lecture class I showed? And if it is a 3-phase 4-wire system, we can connect single-phase load and 3-phase load. But here we are not connecting any single phase load, right? So that's why we haven't connected the neutral point. Okay, this is an important thing. And these are the connections of the isolation amplifier. So I want to just remind all of you, I already said you over there in that table, but I didn't tell you that how many channels we are using today? 4 channels, right?
Yes.
In the first week we used only 2 channels, channel A and B. Now you see this is channel A, we are using B, C and E.
Yes.
So even you can see from the board that we need 2 currents and 2 voltages, right?
Yes.
And the power factor comes automatically, so you don't need to connect anything for the power factor. So 2 currents, 2 voltage means 4 channels. So number 1 channel, which is channel A, it is connected from O and I, so it is measuring current, right? So as because this is current, you have to make it 1. You see, it should be 1. Why it should be 1? Because current is a small value, you don't need to divide by 100.
Yes.
Remember this, I said you in the previous week. Okay. The second one, it is measuring voltage, because this is from O and U. O and U means voltage. When it is voltage, you have to divide by 100. So you divide by 100 here. You see, like this is the button, you divide by 100. Okay. And whenever we will write the formula, we multiply by 100 again. Third one is current. So this is 1. Fourth one is voltage. Again you divide by 100. This is already dividing by 100. Clear? So this channel A with A, B with B, C with C, E with E. And you can see all the grounds are connecting with each other. Clear? So any question, do you have any question from the connection? Now I will take you to the Lab software. You may come a bit closer. We entered into the software as you, okay, and make sure that all the lights are on over here. Otherwise this screen will not appear. Okay. Now how many channels we have to activate? 4.
4.
This one is channel A, we activated, and as because this is AC, it is RMS. Okay, and we will take we'll just put manual at the beginning. Second one is this one. This is channel number B, we activated. This is average value as well, and you select here power factor cos theta 1 over here. Okay. Now this one, you see, it has 3 buttons, 1, 2, 3. The middle one is actually channel number C. Can you see? These are the 3. Which one you have to select? The middle one. Okay. So this one is channel number C. So you have selected the channel number C and make it RMS value. Okay. And channel number E is which one? This one, right? So you see these 2 in the bottom, over here these 2 in the bottom. The top one is the channel number E. You click here. So this is channel number E, make it RMS value. So 4 channels we have activated. Okay. Now you close this one, and here you select the power factor 2 as well. Okay. Now what you have to do, you have to tell your Lab software that what are the formula you have to apply. So click on the calculator, then in the formula, and press in the new button. Whenever you new button, how many? The first one, just we'll see here and we'll write the formula there. You understand? First one is actually current, right? So we'll give the name current 1. Clear?
Yes.
And symbol I1, unit ampere, from 0 to 10. For the current, always decimal place higher, 4. What should be the formula? Only UA1, right?
Yeah.
Because this is channel A. What is the name of channel A? UA1. So as because we did not multiply or divide by 100, this is only UA1. Clear?
Yes.
Okay, great. So this one is done. Then the next one, new. Next one is the voltage one, right? Voltage 1. What is the symbol? V1. Unit volt. From 0 to 100, decimal plus 1. What should be the formula? The name is UB1, but as because we are dividing by 100, so in the formula we have to
Multiply by 100.
multiply by 100. So UB1 multiply with
100.
100. Clear? Next one is the current 2, right?
Yes.
Yes.
This is very simple. Even you can do it by yourself if you understand. Current 2, this is the symbol is I2, unit is ampere, So from 0 to 10, decimal plus 4. Formula, this one's code is UA2. So write UA2, that's it. Okay? Then the last one is voltage 2, right?
Yes.
Voltage 2. So, and the symbol will be V2, unit is volt, from 0 to 100, decimal plus 1. What should be the formula? So the last one is UB2 multiply with
100.
100. UB2 multiply with 100. Okay. So we have defined 4 parameters. So just bring them on your screen. This is your I1, V1, I2, V2. So you see we have just brought them over here. Okay, I can see I1 and V1 is not showing anything. It is asking for some issues. We need to update. We'll save this one. It will not go, no problem. Okay. So do you have any question up to now?
No.
Do you have any question? So, and you see like the cos theta 1 and cos theta 2 is also appearing as because we have selected the RMS and the cos theta. Okay. So is it clear till now?
Yes.
Okay. Take a pause. First of all, we will do the automatic recording. Okay, that means we'll plot the curve of voltage, 2 voltages and 2 currents with respect to time. Okay, so in the recording we will select the automatic. Okay, and here we will put some parameters. So that means we want to put the measurement time 100 milliseconds and interval 100 microseconds. Okay, with a particular trigger UA1. Okay, so everything is ready now. Now we can turn on our source. Exactly. Is it mentioned how much voltage we need to apply? It's not mentioned over here. Actually we have to apply the full voltages. Let me see, power supply on. So our KC lab is ready, connection is ready. So we are now okay, let me sit here because you are closer to me. So I will just turn on the supply now. Okay, so before turning on the supply I need to make sure that the voltage is in the 0 position. Okay, so turn it on. Okay, let's see the voltage and current on the screen so that if there is anything wrong we can see it immediately. Okay, how much voltage will apply? It is not mentioned here, but it is asked to, if it is not mentioned how much voltage you have to apply, you have to apply the full. Full means the rated value. So what is the rated value here? 400. 400 line to line. That means 230 line to neutral. Clear? Okay. So we'll apply line to neutral 400. Okay. Or it is line to neutral, so 230. It's 230. It's line to neutral. Okay. So the maximum it can reach 230. Okay. The rating is how much? You see it, how much is the rating? 400 volts. Yes. Line to line. So that means how much is the line to phase? Divided by root over 3, right? So 400 divided by root over 3 is 230. Right? So it should have maximum 230. But how much we are getting? 211. Because this is the maximum the machine can give. Because we bought it maybe 15 years back. So it has become a bit old. Okay? Yeah. So it cannot give its maximum output. Yes?
What about ampere?
Ampere, the maximum ampere it can handle is 2.5 ampere. But how much we are having now? Only 0.15.
Yes.
Okay, which is way below because we have connected with the resistors. So it is, decreasing the. So now I think everything is ready now, okay, to take the data. How to take the data? Pressing F9. Okay, so we press F9. Oh, super, right? So just have a look. Like just after pressing F9, how many curves we got?
Easy life.
Actually, yes, the KC lab makes life easy.
Yeah.
So
tech engineer make life easy.
so actually in the y-axis we have UA1, UB1, UA2, UB2. So there are some curves we don't need actually. You see, like UA1 we don't want to see. UB1 also we don't want to see. Delete. UA1 don't want to see. UB2 also we don't want to see, right? We actually see 4 curves. I1, V1, I2 and V2. Are you with me?
Yes.
And by the way, can you see like all the curves we cannot see properly. Why? Because some are going up and down. How to bring them on the screen? Just exactly right click here, find minimum maximum. You see the green one, which is the current I1, the current I1 is green, it is now in the screen. Then V1, we do the same thing. I2, we do the same thing. And V2, we do the same thing. Okay, so you can see the curves is looking very nice. Okay, so we have 4 curves actually. 2 are for voltage, 2 are for currents. Okay,
Yes.
so these are actually the output of our 3-phase circuit. Okay, now you will take the picture of this screen, and this needs to be provided in the lab report. Clear?
Clear.
So guys, what we'll do now is we'll go for the power measurement section. Okay, so as you have seen in the CASI lab, that till now we have just seen the voltage and current wave shapes, right?
Yeah.
But to measure the power, as I have explained in the beginning of the lab, that we need actually V1 I1 cos theta 1, because P1 is the multiplication of these 3 and P2 is the multiplication of V2 I2 cos theta 2, right? So how to get them? To get them, we'll delete all the measurements, okay, and we will go to manual recording. You understand? We'll go to manual recording, because can you show here in this table? So in this table we have now we will take the data which to fill up all these values, okay, because this VAB is V1, IA is I1, and this cos 30 plus theta is cos theta 1. So multiplying these 3 numbers will give us P1. Similarly, multiplying these 3 numbers will give us P2. So now we will get these values from the manual recording. Okay, so I have selected here manual recording, and if I go to the display option, new, add new curve, we want to see the value of V1, okay, and I1 and cos theta 1. You see, cos theta 1. So these 3 values, and also new V2, new I2, new cos theta 2. Clear? So you see the table you can see over here in the manual, what I have done, I have brought all the values over here. You understand? So that you don't have to write by hand. If I just press F9, all the values will appear automatically here. You understand? Otherwise, if I did not put them here, what you have to do? You have to take the reading manually and write by hand. You understand? So that's why I have brought them all here. So now you can see we have to take 3 data, right?
Yes.
One for 100% resistance,
1 for 60.
one for 60%, another for 30%. See here how much percentage of resistance we have?
100.
It's already 100, right? So now if I just press F9, you see the values? These are the values supposed to be here, right? So you got the value of V1 I1 cos theta 1, V2 I2 cos theta 2. Clear? So can you find P1, P2, PT, QT from here?
Yeah.
You can find. Great. So the next step is to convert it into 60%. Press F9, your second data.
Yes.
And 30%. Press F9, your third data. Clear, guys?
Clear.
So these are the values you will take with you, and you will do the remaining calculation to put in the report.
Inshallah.
Correct? Okay. So take a picture, please. Then we'll proceed to the next step. Focus here, guys. Okay? Are you with me?
Yes.
Okay. So the next step is to move to the next circuit, right? Because we have dealt with RL circuit. Now instead of L inductor, we'll replace the inductor by the capacitors, right? So before doing any change in the circuit, we need to switch off the power supply. So we have switched off the power supply. Make it off. Now remember, this one was your first. You see, like just remove this one, your first inductor, right?
Yes.
So bring it to the first capacitor. You see, this is your capacitor 1. This is your capacitor 1. Okay? This is your inductor 2. Bring it to capacitor 2. And this was your inductor 3. Bring it to your capacitor 3. You see, this is capacitor 1 2 and 3. Inductors were placed vertically, but they have been put horizontally over here, right? So the second point, these and these, they need to be shorted, isn't it?
Yes.
Like remember, like the bottom parts were shorted there, so they need to be shorted as well. So we'll just short from here to here and from here to here. And the remaining everything is same like before, right? So there is nothing to change. So come here in the CASI lab. What we'll do, these are the previous data. We have already taken the picture. So we'll go to the measurement and delete it. Okay? Now we'll switch on the supply once again.
Yeah.
Apply the voltage, the maximum voltage, 230 volts. It's great to apply 230 volts, right? Because when we did the circuit lab, the maximum voltage we're applying is 10, 15, we're very careful and so on. Now 230 volts, we have grown up to level 3. Applying 230 volt is fun. So just have a look. So initially we'll start with 100%, right?
Yes.
So just press F9, okay? And then 60% is F9 and 30% again F9. So the values we are getting, these are the values for our RC circuit, okay? Are they all fine? They're fine, I think. Is there any change? There is nothing. They look like very similar, isn't it? They look like similar, I think.
No.
Whatever, I think they're fine. They're fine. Yes.
Yeah,
So use the values to calculate the remaining parameters. Okay.